Hello, Chemistry 20. This is our 9th lesson in the Quantities in Chemical Reactions unit. This is percent yield and percent error. In this lesson, we will explore different types of experimental error. We will look at the calculations of percent yield and percent error and work through 3 examples. Experimental error. Experiments often involve a degree of error, as no measurement can ever be exact. Experimental error is the reason why we say quantitative reactions proceed to 99% completion. We cannot say that they will proceed to 100% completion because of experimental error. Below are a few examples of experimental error. Instrumental error. The instruments used are only precise to a certain degree. For example, our weigh scale may only measure to 2 decimal points. Chemical purity. Chemicals come in a wide variety of grade and purities. Chemicals may not be 100% pure. Side reactions. When we are observing a reaction in the lab, there may be additional reactions occurring that we cannot account for. Qualitative judgment. These are measurements that have to be made by humans. For example, one student may observe the color of a solution slightly different than another student. And finally, loss of substance. This can occur when particles stick to glassware, pass through filter paper, or dissolve in water. Human error is not considered an experimental error. It is simply a mistake that occurs and should be corrected. For example, spilling a solution is not considered an experimental error. Percent yield. It is important to be able to account for such experimental errors in chemical reactions. This can be done by calculating the percent yield. When we talk about the word yield, we refer to the amount of product produced in a chemical reaction. Percent yield is equal to the actual yield divided by theoretical yield times 100%. The actual yield is the amount of product produced during an experiment, or this value must be provided in the question. The theoretical yield is calculated using graviometric stoichiometry and is the amount of product that should be produced if there were no experimental errors. Percent error. When evaluating an experiment, you can use the percent error to decide if the experiment is valid. If the percent error is less than 10%, the experiment is considered valid. If the percent error is greater than 10%, the experiment is considered invalid. Percent error is equal to the actual minus the theoretical divided by theoretical times 100%. The vertical lines in the equation refer to absolute values, meaning that regardless if the value calculated is positive or negative, we will always express that value as a positive number. Example number 1. In an experiment, a student calculates the mass of a product to be 100 grams, but only measures 93.5 grams of product. Calculate the percent yield and error. Is the experiment valid? Pause the video and attempt this example. In this question, we have to determine what is the actual yield and what is the theoretical yield. Remember, theoretical yield is calculated. It says a student calculates the mass of product to be 100 grams. Therefore, 100 grams is the theoretical yield. And remember, actual yield is measured in an experiment. It says only 93.5 grams of product were measured. Therefore, 93.5 grams is the actual yield. Therefore, to calculate the percent yield, we take the actual yield, 93.5 grams, and divide it by the theoretical yield, 100 grams. And finally, times that value by 100%. The percent yield of this experiment is 93.5%. To calculate percent error, we take the actual minus the theoretical and again divide by the theoretical and times that value by 100%. As a result, the percent error of this experiment is 6.50%. That means that this experiment is considered valid. Example number 2. Calculate the percent yield when 24.8 grams of gaseous propane burns to produce 15 grams of water vapor. Pause the video and attempt this example. Percent yield refers to the amount of product produced. This is going to be a combustion reaction where we are burning propane. Propane is then going to be a reactant, and we are producing water vapor. Therefore, water vapor is going to be the product. We have to calculate the percent yield of water vapor. 15.0 grams is given in the question, therefore it will be the actual yield. To complete this question, we have to write a balanced chemical equation. We then have to perform a gravimetric stoichiometry calculation to find the theoretical mass of water vapor. Then finally, we can calculate the percent yield of water vapor. We can see the chemical equation for the combustion of propane. We need the molar mass of propane, which is 44.1 grams per mole, and we also need the molar mass of water vapor, which is 18.02 grams per mole. We now have to perform a gravimetric stoichiometry calculation. We are going to start with the mass of the reactant propane, 24.8 grams. We are then going to divide by the molar mass of propane to first get the moles of propane. Once we have the moles of propane, we can then use the molar ratio, which is a 4:1 ratio, to calculate the moles of water vapor. Once we have the moles of water vapor, we can then times it by the molar mass of water vapor to get the grams of water vapor. As a result, the theoretical yield of water vapor is 40.5 grams. We can now simply perform our percent yield calculation. We have the 15.0 grams, which is the actual yield and which was provided in the question, and divide it by 40.5 grams, which is our theoretical yield, which we calculated. If we times that by 100%, we are left with the percent yield of 37.0%. Example number 3. 25.2 grams of sodium chloride reacts with solid lead to produce solid lead 2 chloride. If the percent yield of the chemical reaction was 8.87%, calculate the actual yield of PbCl2. Pause the video and attempt this example. To calculate the actual yield of PbCl2, we first need to find the theoretical yield of PbCl2. To accomplish this, we need a balanced chemical equation. We are going to need the molar mass of sodium chloride, which is 58.44 grams per mole, and also the molar mass of PbCl2, which is 278.10 grams per mole. We can then perform a graviometric stoichiometry calculation to find the theoretical mass of PbCl2. We have to then first start with the mass of the reactant, sodium chloride. We will take the 25.2 grams of sodium chloride and divide it by the molar mass of sodium chloride. This will put our value into moles of sodium chloride. We can then use the molar ratio of 1/2 to calculate the moles of PbCl2. Then we can times the moles of PbCl2 by the molar mass of PbCl2 to get our answer into grams of PbCl2. The theoretical yield is 59.9599 ... grams. Remember, do not round this value yet. We can then rearrange our percent yield calculation. We already have the 8.87%, which was given in the question, and we just calculated the theoretical yield, which is 59.9 ... grams. If this calculation is rearranged, the actual yield is equal to the percent yield times the theoretical and divided by 100%. The actual yield of PbCl2 in this experiment is 5.32 grams. Moving forward, we will explore the concept of limiting reactants.